Welcome to the Deep Dive, episode 5. We're halfway done in the series. This is the latter half. So, let's get to it. First question. An athlete finishing a running event suffered from a cramp in his leg. What is the chemical compound which is produced in muscle cells causing the cramp? Have you ever experienced a cramp? I've experienced quite a lot of cramps. Like, one of the places, not the best, the worst places to experience is the calf muscle that's between your ankle and your knees, one downside, the other side of the leg. That muscle is very isolated muscle, so when you use it, like running, jumping, that muscle gets cramped a lot. So let's go through every option and see if that option may cause cramping. Carbon dioxide. Carbon dioxide is a gas produced in abundance during exercises but does not cause cramps. Carbon dioxide gets produced a lot in exercises, but it does not cause any cramps. Ethyl alcohol is not produced by our body. Alcohol is produced by yeast mostly, not by us. Okay. Then acetic acid is not produced by our body and it is found in vinegar. Then we come to the correct answer. Lactic acid, on the other hand, is produced in our body when our body cannot supply enough oxygen to the muscles to support aerobic respiration. Aerobic respiration is respiration with oxygen. In such situations, the muscles switch to anaerobic respiration, which does not require oxygen but produces lactic acid as a byproduct. The buildup of lactic acid in the muscles can lead to a decrease in pH levels, causing the muscles to become more acidic. So lower pH means acidic, higher pH means basic. pH 7 means neutral. Okay, just remember that. This increase in acidity can interfere with muscle contraction and contribute to the sensation of muscle fatigue and cramping. So the answer is 3. Next question. A warm-blooded homeothermic animal and a cold-blooded poikilothermic animal respectively are. So homeothermic animals, warm-blooded, such as mammals, that means us, and birds, are able to maintain a relative constant body temperature regardless of external conditions. They regulate the internal temperature through physiological mechanisms like shivering or sweating. We call this regulating the internal things, not just temperature, internal things, homeostasis, like keeping a certain level in our body in different mechanisms. We call it homeostasis. Example, you have pigeon, bear, rat, whale. Then we have poikilothermic animals, cold-blooded, like reptiles and amphibians. They do not regulate their body temperature internally. Instead, their body temperature fluctuates with changes in the environment. They rely on external sources of heat, such as sunlight, to warm up, and they seek shade or cool environments to lower their body temperature. We have frog, rat snake, gadawilla. You know gadawilla, right? Rat snake. Then we have crocodile, tortoise, like that. So the answer is number 1, pigeon and frog. Pigeon is a bird. They are homeothermic, and a frog is an amphibian. They are poikilothermic. 23rd question. Which arrangement can be used to obtain voltage of 3 volts from 2 rise cells, each with an electromotive force of 1.5 volts? One is 1.5 volt, one battery. We move in 3 volts from the whole circuit. Okay. So there are 2 types of circuit configurations. One, we call it series. 2, we call it parallel. In series, where components are connected end to end, forming a single pathway for current flow, when batteries are connected in series, their voltage adds up. So if you connect 2 3-volt batteries in series, the total voltage is 6 volt. The same thing goes for resistors. If you connect 2000 ohm resistors in a series, it comes as 4000. So, in a parallel circuit, components are connected across multiple pathways, allowing current to flow through each component independently. When batteries are connected in parallel, their voltage remains the same, but their capacity or the total current capacity increases. So, if you connect two 3-volt batteries in parallel, the total voltage remains 3 volts, but the capacity doubles. This is really good for places where you have certain voltage, but you have to keep for a longer periods of time. Certain voltage for a longer periods of time, you can use parallel batteries. Okay, so the option, look at the question. Option 1 and 2 is in parallel, and option 3 and 4 are in series. But look closely. The second option does not allow any current to flow. So is the fourth option, due to how the batteries are connected. In a series, the battery should be connected from positive to negative, or the other way around, or negative to positive. Never negative to negative or positive to positive. So the answer is going to be 3. 24th question. What is the metal that reacts with hot water but not with cold water? We have a bunch of options. First option, sodium. Sodium vigorously reacts with cold water, forming sodium hydroxide and hydrogen gas. Sodium just sometimes just explodes. You can find videos on YouTube of sodium just being exploded. I watched one when I was very young. It was like a brick of sodium, not just a tiny speck. It was a brick of sodium getting thrown into a pond and it just exploded. The thing is, when I was young, I was like, oh my god, that's so cool. But now I'm looking at it, I'm like, none of those fish and aqualife in that pond is going to survive because sodium hydroxide is extremely basic. And it's going to be poison. Well, all the fish is going to be there. Anyways, aluminium doesn't react with hot or cold water. Calcium vigorously reacts with cold water, forming calcium hydroxide and hydrogen gas. Magnesium does not react with cold water but reacts with hot water, forming magnesium hydroxide and hydrogen gas. Answer is 2. 25th question. What is the correct statement about COVID-19? Let's talk about viruses in general. COVID-19 virus. A virus is much smaller than even bacteria. 20 to 300 nanometers in size. Even the best optical microscope can only see down to 400 to 700 nanometers, the best one, okay? These numbers aren't necessary to remember, by the way. These are just for your knowledge. So, they can't be observed by any optical microscope. Another, viruses do not carry out any metabolic activities. A virus can have DNA or RNA, but never both. Okay, they are surrounded by a protein called a capsid, which provides protection, and not a nucleus. This DNA or RNA is covered by something called a capsid, not a nucleus. Okay, virus shows living characteristics such as reproduction and the ability to evolve, but they lack key features of life such as metabolism and ability to maintain homeostasis, leading to debate over whether they are truly living beings, because it still is not really viruses are not classified as either living or non-living. It's something that's in between. Some scholars say that they are not living, others say that they might be living entities. So the answer is 4. Today's episode was very short, and I think a lot of things are here to remember. So watch it again if you want, or just look at the explanation slides, take screenshots and read them. A lot of information was in today's episode, but not a lot of time. So that's a good thing. So I'll see you in the next episode where we're going to discuss 26th question to 30th question. So subscribe, like, comment, all that jazz.